Okay, so I did a little preliminary work on this one. I had questions on 2 and 7. On 2, I started to do more work than I needed to. Does Rolle's theorem apply on the interval from 0 to 12? Rolle's theorem is the one that says um, that if one point to another point, and they're exactly at the same level, so f of 0 looks like it's 100.5, and f of 24 looks like it's 100.5. So if they start and end at the same spot and it's continuous the whole way, then it must have a slope of 0 at least one spot in between, which is clearly does, may even have a couple times. But so 0 to 24 works because f of 0 and f of 24 are the same. So Rolle's theorem applies. But on 0 to 12, it doesn't apply. So f of 0 does not equal f of 12. So Rolle's theorem doesn't apply. That doesn't mean it can't have a slope of 0 somewhere in between. Like I said, it may somewhere in there. But it doesn't apply from 0 to 12 just simply because f of 0 and f of 12 are not the same. And then on 7, it wanted us to find the points of inflection using a graphing utility. So the preliminary work I did for that one was plentiful because I had to find points of inflection as a second derivative thing. So original function, first derivative, and then the second derivative I had to use a product rule. So that was my first, and that was my second. So here's my first times the derivative of the second using a chain, plus second times derivative of the first using a power rule and a chain rule twice. So that's pretty lengthy. And then I just cleaned it up a bit here. And then once I got there, it really, points of inflection are just where the second derivative equals 0. So I went ahead and I typed in that second derivative function, which was, this is the original function, so I'm going to get rid of that because I realized they had a picture of it in the book. That's the second derivative function. And then my window, I did 0 to 24 hours, but I only really care about its 0, so I only went -1 to 1 on the y's. And I got maybe 6 of them. 1, 2, 3, and so on. And then I'm just going to do second trace zeros, and I'm going to do it however many times there were, 6, I guess, or 5. 1, 2, 3, 4, 5, 6. So second trace 0, I'm going to look for, I'll find the first 0. We'll do a left bound and a right bound. Enter, enter, enter. And 2.35 is the point of inflection, the first one. And we can kind of see that on the graph here. So I was starting this, and I saw this curvature, and I thought, okay, it's concave down, and then here it's definitely concave up. So somewhere right around there I knew was a point of inflection. Then it's concave up, and then it's concave down again, so there must be a point of inflection there. So the first one we found was obviously that 2.35 number. And then you would just go through the other 5. 1 second, bud. You'd go through the other 5, and then 1, 2, 3, 4, 5, 6 are kind of the ones I eyeballed anyway, which I'm sure will line up with 1, 2, 3, 4, 5, 6. So I just traced it once for you, but that's how you would do that. So I'm going to leave it there. If you want to take a peek at it, obviously you could have paused at any given time, but that's a lengthy thing there.